Hello class, today we're going to talk about transformational geometry. What is it and what do we need to know about it? Now in part one of this video, we talked about the definitions. We talked about the four parts, the four transformations that we need to know. So now we're going to break it down. So for part two, we're going to talk just about translations. So let's review that definition real fast. A translation is a move without rotation or resizing. It is a slide. So I take this figure and I just slide it into a new position. It has no effect on congruency and it has no effect on orientation. Now, in the 8th grade, we have to look at each one of these transformations in relation to a coordinate grid. Okay, so let's do that. So here I have a coordinate grid. I would like for you to translate the object I'm about to draw 4 units to the right and 3 units down. Okay, so let's see if we can do that. Let me put a object on our grid. So let's say we have the object and we say that it's right there. Okay, so there is our object. Now this says to translate it 4 units to the right and 3 units down. Well, when we look back at the definition and we look back at what the slang of translation is, it means that I'm just going to slide the figure. We'll slide it around. That's all it means. So I'm going to take this figure here and I'm going to slide it 4 units to the right. 1, 2, 3, 4, and then 3 units down. 1, 2, 3. Now what I'd like for us to do, let me put it back in its original location, or in this location right here. Okay, now I want us to focus on a particular point. So let's take a look at this point right here. Well, what is that coordinate? Well, that coordinate is at 2, and then 1, 2, 3, 4, 5. 2, 5. So that was the original point that we have. Okay, so now I need to move this object 4 units to the right. So 1, 2, 3, 4. Okay, and then 3 units down. 1, 2, 3. And what I'd like to do is I want to look at what happened to that point as we moved this object. Okay, well this point moved to 1, 2, 3, 4, 5, 6, comma, 2. Okay, so whenever we're looking at this particular translation, okay, what I need to know is what happened to that point. Because what we have to do in 8th grade is we've got to write this as an algebraic representation. Okay, so what we're going to do is we're going to look at this original point, and we will call that original point X and Y. Okay, that X and Y does not mean that the X is positive and the Y is positive. It could be negative depending upon where the original shape began. Okay, but what we want to do is we want to look at what happened to my X coordinate. Well, what did I do to this 2? Okay, it actually changed to a 6. Well, what caused that to change to a 6? Well, I slid it along the x-axis 4 points. So that's the 4 units to the right. So what we did to that coordinate when I moved it was I moved that x coordinate 4 to the right. So algebraically what that looks like is I take that x value and I add 4 to it. Okay, and then it moved 3 down. Okay, so it went from a 5 to a 2. So that y coordinate went down 3. So that becomes our algebraic representation. Okay, so we could actually take each one of the original points, if I were to put that back in its original location, and for each of those corners, I could perform this transformation on it and get the new points. And that's what a translation is about. That's what this transformational geometry is about in 8th grade, is looking at when I perform a transformation, whether it be a translation, a rotation, a reflection, or dilation, what happens to the coordinates. And this is what happened to this one. Let's look at this one more time. Okay, let's say I take another object. Let me do a new object here. Okay, so this one's going to look like very similar, still a rectangle. Okay, but it's a different shape. So let's look at another point. Let's look at this point right here. Okay, I'm going to take that point. I'm going to translate this entire object, but I only want to focus on that one point to find out what happens. So this time I want to translate it 6 units to the left and 4 units up. So what is this original coordinate first? The original coordinate is 2, 2, 1. So now I'm going to perform the translation. Okay, so I'm going to move it 6 units to the left. 1, 2, 3, 4, 5, 6, and then 4 units up. 1, 2, 3, 4. All right. Now, what happened to that point that we were looking at? Well, that point went 1, 2, 3, 4, 5, 6 units to the left. So it's now at -4. And 1, 2, 3, 4 units up. So it's now at 5. Okay, so if we were to write the algebraic representation of that, I will take my x value and I will subtract 6 because I moved it left 6. And I will take my y value and I will add 4. Okay, because I went 6 left and 4 up. And that would be the algebraic representation for that. Now, why do we need to know that? Well, on the test that we get to take at the end of the year, they give you questions like this. Now, this question is not about a translation. It's actually about a dilation. Circle 1 is dilated with the origin as the center of dilation to create circle 2. Which rule best represents the dilation applied to circle 1 to create circle 2? Well, when we look at the answer choices, we see H and J. Well, when I'm adding to my X and my Y, or I'm subtracting from my X and my Y, I know those are translations. They are not dilations. So I can automatically eliminate those because I know those aren't going to be part of this particular problem. And that's one of the reasons why we have to understand the algebraic representation, is because that's what the state of Texas says we need to know about. Okay, we need to understand how these shapes are affected on a coordinate grid when performing a transformation. Now that's the end of part 1, or part 2, excuse me, when we talked about translations. So stay tuned for part 3.